My name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover the chain rule, total derivative, and problems on chain rule and total derivative. Let us see the chain rule definition first. Let z is equal to f of u comma v, means f is a function of u and v. Again, in turn, u is a function of two variables x and y is also a function of two variables x and y. So we define the chain rule as follows. Since z is a function of u and v, we can differentiate z with respect to x and y. So dou z by dou x, that can be written as, since z is a function of u, first let us write dou z by dou u, right? But u is also a function of x, so into dou u by dou x, plus z is also a function of v, so I can write dou z by dou v. But v is also, this is v is also a function of x, so I can write dou v by dou x. These are all completely with respect to x. Now let us differentiate this function with respect to y partially. So we get dou z by dou y equal to, say z is a function of u, I can write z with respect to u, so dou z by dou u. Again, u is also function of y, so I can write dou u by dou y, plus z is also a function of v, so I can write dou z by dou v. But v is also a function of y, so I can write dou v by dou y. This is how we differentiate chain rule. So these are the referred to chain rule of partial differentiation, and this above rule can be extended to the functions of having more than two variables. Z is a function of two variables u and v here. Suppose if there are three variables, say u, v, w, in that case accordingly we will be getting the partial derivatives, right? Next, let us see the definition of total derivative. Let z equal to f of x comma y be the function of two variables x and y, where x is equal to function of t, single variable, and y is also a function of single variable t. Then z becomes single variable t, because we substitute x and y in this function. All the variables x and y will be converted to function of single variable, that is t. So we define the total derivative of z with respect to t is dz by dt equal to dou z by dou x into dx by dt. We can observe here, first derivative is partial derivative and second derivative will be a plain actual ordinary derivative. Why? Because z is a function of two variables. Whenever we have function of more than one variable, we differentiate that particular function partially, means dou z by dou x or dou z by dou y, like that. Here I wrote dx by dt. Since x is a function of only one variable t, I can write dx by dt, right? Again, z is also a function of another variable, say y. I will write dou z by dou y. But y is function of single variable t, so I can write into dy by dt. This is not dou y by dt, dy by dt. This result is called total derivative of the function z. This can also be written in the direct derivative form is dz equal to dou z by dou x into dx plus dou z by dou y into dy, right? Now let us see a few problems on this chain rule. U is a function of RST. There are three variables RST. Again, in turn, RST are functions of XYZ, composite functions, function of functions. RST are functions of XYZ, and U is a function of that three functions RST. Then he's asking to show that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to 0. First let us write by chain rule. By chain rule, dou u by dou x can be written as, since u is a function of r, first let us write dou u by dou r. Now we can write dou r by dou x plus dou u by dou r into dou r by dou y plus dou u, this is dou u by dou s, and this is dou s by dou x. Next, s u is a function of t, so we can differentiate u with respect to t. Again, t is also a function of xyz, so I can write into dou t by dou x. So what we'll be getting, dou u by dou x is equal to dou u by dou r into dou r by dou x. Dou r by dou x means you differentiate r with respect to x, so that is 1 by y plus dou u by dou s, this term keeping as it is, dou s by dou x minus y by x square plus dou u by dou t, this first term let us write as it is. What is dou t by dou x? So x by y by z, this one. So here we will be having dou s by dou x. There is no x term here, so I'll be getting 0, right? Plus dou u by dou t into dou t by dou x, that is minus z by x square. So what we'll be getting, now multiply the first term x into dou u by dou x. So let us multiply this dou u by dou x with x. So I'll be getting dou u by dou r into x by y, isn't it? Plus second term is 0 minus dou u by dou t. If you multiply this term with x, denominator 1 x will get cancelled and this will be getting z by x. Let it be equation 1. Now again, first let us find dou u by dou y, then multiply this with y. By chain rule, dou u by dou y can be written as dou u by dou r into dou r by dou y plus dou u by dou s into dou s by dou x plus dou u by dou t into dou t by dou x, right? Dou u by dou r, what is dou r by dou y? R is given as x by y. You differentiate r with respect to y, so I'll be getting minus x by y square. Because x is constant, we have to write as it is, minus x by y square. Next, plus dou u by dou s into dou x by dou s, dou s by dou x, that is 0, plus dou u by dou t into, what is dou t by dou x? You differentiate this t with respect to x. So what is t here? T is z by x. So dou t by dou x can be written as minus z by x square. Sorry, this is with respect to y, this is with respect to y, I'm sorry. So dou u by dou s into dou s by dou y, that is dou u by dou s into, what is dou s by dou y? S is given as y by z. Dou s by dou y is 1 by z plus dou u by dou t into dou t by dou y value is 0 because in the function t there is no y term, right? We got dou u by dou y only. I have to multiply this with minus sign. So y into dou u by dou y, that can be written as, if I multiply with y, one y will get cancelled in the numerator, dou by dou r into dou u by dou r into minus x by y, right? Next, dou u by dou s into x by z, dou u by dou s into y by z. This is dou u by dou r into dou r by dou y, right? Plus z into dou u by dou z. What is dou u by dou z? We didn't fair. Dou, first let us find dou u by dou z. So this term dou u by dou z is u z equal to dou u by dou r. This will be fixed as it is into dou r by dou z, that is 0, plus dou u by dou s into, so dou u by dou s into 1 by z, dou u by dou r, dou u by dou s, dou t by dou x. So dou s by dou z into, we want dou u by dou z. So first let us write by chain rule. How we'll write? By chain rule, dou u by dou z can be written as dou u by dou r into dou r by dou z plus dou u by dou s into dou s by dou z plus dou u by dou t into dou t by dou z. This is the chain rule how we write. So dou u by dou r fixed, dou r by dou z value minus x by y, dou r by dou z. So we don't have any z terms in r because r is x by y. So with respect to z derivative it becomes 0 plus dou u by dou u by dou s into dou s by dou z. With respect to z, if we differentiate s, we will be getting minus y by z square, minus y by z square plus dou u by dou t into, what is dou t by dou z? T is z by x. I want dou t by dou z, that means 1 by x. So I have to multiply this with y, z into dou u by dou z. So z into dou u by dou z. Therefore z into dou u by dou z, that can be written as dou u by dou r into, what is dou r by dou z? 0 plus dou u by dou s, what is dou s by dou z? Minus y by z square plus dou u by dou t, what is dou t by dou z? Into 1 by x. So I'm multiplying with y, right? Next, therefore we have to add this first equation, second equation and third equation, adding 1, 2 and 3. So x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z, that equal to, if we add, all the three terms will be getting cancelled and hence proved. Right. Thank you.